Okay, in this video I want to look at 17.1 and 19.1, the lines and angles and trig functions. Basically what we have are, I want to look at two specific kinds of angles here. One is if that angle is less than 90 degrees. Then it's called an acute angle. And I use this symbol, a circle with a line through it. That's a Greek letter theta, and I use that quite a bit for mentioning angles. The other is phi, and phi is a circle with a vertical line through it. Again, that's a Greek letter. Those are ones that I use quite a bit. So we know that a circle starts at 0 degrees, rotates through 180 degrees, and then back through 270 degrees, and back to 360 degrees. There's 360 degrees in this circle. We look at the angle between 0 and 90 as acute angle. If it's more than 90, if it goes from here to here, then it's an obtuse angle. Now, there's two situations that I want to consider. Is you got two angles. Here's one, theta. Phi is the other one. If those two angles add up to 90 degrees, then they're said to be complementary. Okay? And phi is the complement of theta. Theta is the complement of phi. If they in fact add up to 180 degrees all the way around to this point right here, then they're said to be phi is a supplement of theta, theta is a supplement of phi. Pretty straightforward. That's all we need to know. Now there are times whenever we look at negative angles, and I'm not going to worry about that. If I have an angle that's, say, here, okay, and this is the angle that I'm talking about. Here's theta. Normally what we would do is we would look at from here all the way around. I can do that, or I can look at a negative angle. We're not going to deal a whole lot with negative angles. I just simply mention them because they do come up in conversations, and I want you to know what they are. I'm not going to ask you any questions about this, but they do exist. We do work with them. Negative angles instead of looking at this entire angle here. Sometimes in trig, when you get deep into it, you'll have to look at this angle right here. And sometimes in trig, you have to look at angles that in fact lap all the way around this thing. Something like this. This is the angle that we're talking about. This green line actually is more than 360 degrees. Here's 360 degrees here, and we're talking about another 90 plus. And again, I'm not going to ask about that. You'll see it in trig, but not in this class. You need to know obtuse, and you need to know acute. You need to know complement, and you need to know supplement. Okay, pretty straightforward on the lines here. What we're going to look at are two lines that are parallel. L1 is parallel to L2. And T, the red line, is called a transversal. L1 is parallel to L2, and T is a transversal. It creates angles. Here's an angle here, angle 1. Okay? Angle 5 corresponds to that angle 1. If you would, picture breaking these two pieces up into two pieces, two separate pieces, and you can see that they correspond. 4 would correspond with 8, 2 corresponds with 6, 3 corresponds with 7. Those are corresponding angles. and those values are equal. Anytime you have two intersecting lines, and it doesn't matter what they are, what they look like, you're going to form four angles, A, B, C, and D. Now, A and B are vertical angles, C and D are vertical angles. So in this example, 1 and 3 are vertical angles, 2 and 4 are vertical angles, 5 and 7 are vertical angles, 6 and 8 are vertical angles. And again, the measure of vertical angles are the same. Okay, if one's 62 degrees and the other one's 62 degrees. Now, we can also talk about alternate angles. Alternate angles appear on opposite sides of that transversal. So 1 and 3 are opposite angles, 1 and 6 are opposite angles, 1 and 7 are opposite angles. And likewise 2, 4, 2, 5, 6, 8. Now we can talk about exterior angles. Exterior angles occur on the outside of each of the L's. 1 and 2 are exterior angles, 7 and 8 are exterior angles. We can talk about interior angles. Interior angles occur on the inside. 4, 3, 5, and 6 are interior angles because they lie inside of L1 and L2. Okay, so let's take a look at alternate exterior angles. They have to lie on alternate sides of the transversal, and they have to be exterior. So 1 and 7 are alternate exterior angles. Let me remove that blue line right here. Okay, so 1 and 7 are alternate exterior angles. 2 and 8 are alternate exterior angles, and their measures are equal. Alternate exterior angles are in fact of equal measure. Now if I look at alternate interior angles, again they have to lie on opposite sides of the transversal and they have to be inside. So what have I got here? What are my alternate interior angles? Well, 4 and 6 are alternate interior. 3 and 5 are alternate interior. And alternate interior angles are equal also. Pretty straightforward. Now, an example that I'd like to use here is let's just take an example of two parallel lines. Alright, and I'm going to tell you that this angle right here is, say, 45 degrees. Now, it doesn't look like it in the picture, but let's just assume that it is 45 degrees. What I'll ask you to do is tell me what the rest of these angles are. Well, I know that the vertical angle, and I'll do that in blue, I know that this vertical angle is 45. I know that alternate interior angles are 45. I know that this vertical angle is 45. And I could have said that this 45 and this 45 right here are corresponding. These are vertical. I could say that alternate exterior angles are equal. But the bottom line is you can use any of these methods over here to say that those values are equal. All right, now what's this one right here? What is the value of this angle? Well, what I can know is that they're supplementary. So I know that this angle, 45 plus the x, whatever that happens to be, has to add up to 180. So all I have to do to find this x is take 180 and subtract the 45. And when I do that, I should get 135 degrees. So I know now that this angle is 135 degrees. I'm going to go through the same process. Here's a vertical angle, 135. Here's an alternate interior angle, 135. And another vertical angle, 135. So I've completed, once I know one angle in this parallel lines, these two lines are black lines are parallel, cut by transversal T, I can fill in all the angles if I know one of them. And I will ask you a question like this. This will be one of the questions that I'll ask you on the test. Okay. Let's look at trig functions. Trig functions sound really odd. They're not. It's just a fraction, that's all. All this is a fraction. If I look at this thing, first of all, I have to consider a right angle. It has to be right angles before I can consider the trig functions in the ratio. Okay, I've got the opposite, and here's the angle that I'm interested in. Here's theta, right here. Okay, this is opposite the angle theta. This one's adjacent to angle theta, and always opposite the right angle is the hypotenuse. And the hypotenuse squared is equal to the opposite squared plus the adjacent squared. Or I can say that h, in fact, is the square root of the opposite squared plus the adjacent squared. Okay? Now I can do the Pythagorean theorem. This is called the Pythagorean theorem, by the way. And let's take a look at this one right here. Okay? I know that this is the hypotenuse, 5, and this is the opposite, 3. So I know that 5 squared is going to be the adjacent squared, a squared, plus 3 squared. So I know that 25 is going to be that a squared plus 9. If I subtract 9, I should get 16 is equal to a squared, and 4, actually if I take the square root, it's going to be plus or minus 4 is equal to a. Now consider this. What is a negative 4 inches? Well, I don't know. So the idea of the negative doesn't make sense, and we only consider the positive. So I know now that this thing is going to be 4. 4 squared plus 3 squared does equal 5 squared. 16 plus 9 does equal 25. Okay? So now I can calculate the sine of theta. The sine of theta is the opposite side divided by the hypotenuse. The opposite side was 3, and the hypotenuse is 5. So it's going to be the sine of theta is 3 over 5, where the sine of theta is 0.6. You can use either the fraction or the decimal, doesn't make any difference. Now that I know this adjacent side is 4, I can say that the cosine of that theta is 4 over 5. The adjacent side divided by the hypotenuse. Adjacent divided by hypotenuse. Lastly, the tangent of theta is the opposite side divided by the adjacent side. So the tangent of theta is 3 divided by 4. Opposite divided by adjacent, which is 3/4 or 0.75. Now, I can go the other way. Now that I know the sine, cosine, and tangent, I can try out one of those things. And I know that theta is the angle whose sine is 0.6. I know that the sine of theta is 0.6. So on my calculator, I can use this function right here. Now that's basically second sine, which is, I've cut it off. I'll show you on the calculator here. Let's see if I can find a calculator. Use the second button right here and the sine button right here. Right above the sine, you see sine to the -1. That's the buttons we're going to use. Well, let's try that. So I'm going to do, according to this, second sine, and I get that sine to the -1. It's the angle whose sine is what? 3/5? Well, let's try that. 3 divided by 5. And close the parentheses. And I push enter. And I get 0.6. Wow. That's a very, very small, it's a ½ degree. That doesn't seem quite right. Well, the problem that we have here is two different kinds of measure. We can measure this thing in radians or we can measure it in degrees. Alright, so I'm going to look at mode. So let's go back to my calculator and choose mode. Mode is right here next to the second button. So if I click on mode, it gives me all kinds of different options that I can set up for my calculator. I've got normal, scientific, or engineering displays. I can float the decimal, or I can have it as 2, 3, 4, 5, whatever decimal places that I want. And this is the one that I'm interested in, radians or degrees. So if I cursor down to radians and over to degrees and push enter, it lights up degrees. And that's what I've done in this example right here. Here's where I chose mode. Come down to the third and choose degrees. That's what I want to do. Okay? So now let's go back and recalculate that. Alright, we'll do second, quit, and I want to do sine of 3 divided by 5. That's what I said earlier. And I see that the angle is 36.86 degrees. That's what I've got on this display right here. So this one, the first one, 0.64, is measuring in radians, and this one's measuring in degrees. And it depends upon how they have this piece right here, how you have this piece set. And you want to set it to degrees. Alright, let's talk about radian measure. What does that mean? Well, if I have a circle with a radius of 1, here's my radius right here, and the radius is 1. At this point, all the way around, I know that the circumference of the circle is 2 times pi times r. But I know that r is 1, so the circumference of the circle is simply 2 pi. And that's given in radians. 2 pi radians. I know that it starts at 0, it goes to 90. Well, it goes to 2 pi over here. This is going to be 2 pi. Well, half of that would be 1 pi. So here's 1 pi radian, which is, I know, is 180 degrees. If I divide that by 2, I'll get pi over 2, and I know that's 90 degrees. Well, this is This is kind of weird, isn't it? Let's look at this one. If I know that the circumference is 2 pi, and pi is about 3.14, if I take 3.14 and I multiply it times 2, I should get 6.3. So that means that the distance all the way around here is 6.3. Now I've drawn this incorrectly. It's not 6.3 in 3 different cases. Okay? I won't have 3 of those 6.3s. Let me erase those so I can eliminate the confusion. All the way around is 6.3. Assuming that this is the radius is 1. Now obviously it would change if that radius were 2. The bigger circle is going to have a greater circumference. Okay? But let's talk about the radians. What's the radian? 1 radian is where the length of the arc is equal to the length of the radius. Well, this radius right here, I just called it R. It could be anything. It could be 1, it could be 10, it could be 2.5. The distance along this arc, if I could measure that same distance that this is, that's called 1 radian. Okay? That's where the radian is where the length of the arc is equal to the length of the radius. Now, I want you to think about something. Now, what I'm going to do is I'm going to drop a perpendicular right here. I'm going to drop a perpendicular right here. And this is the figure that I will get. I'll have some particular angle, theta. The radius is going to be 1 in this case. And I want to know what this value of y is. And I want to know what this value of x is. Well, I know that the sine of theta is y over 1. Opposite over hypotenuse. I know that the cosine of theta is adjacent over hypotenuse, so it would be x over 1. So, the sine of theta is y, and the cosine of theta is x. So anytime I want to find a point in the Cartesian system, I know that xy, if I have a Cartesian system, and I just arbitrarily pick a point, whatever that point is, right here it is, I know that this is xy, or it could be cosine theta, sine theta, whatever that value is. That's something to hang on to. Alright, now what do I know? I know that 180 degrees is pi radians. If I go back to a circle up here, if I go back to my circle, way up here on the top, I said that 180 degrees was pi radians. And I'm going to use that right here, down here at the bottom. 180 degrees is pi radians. Well, let's take 180 degrees, and we say that that's equal to pi radians. And I'm just going to put an RAD just to make sure that you understand it's radians. Well, let's divide both sides of that equation by pi radians. And if I divide both sides of that equation by pi radians, I get that 180 degrees divided by pi radians is 1. And I can do exactly the same thing if I take that same equation, 180 degrees is pi. If I divide both sides of that equation by 180 degrees, I get pi over 180 is 1. So these are the two things that you want to remember. Actually, you only have to remember one of them. Okay? And the reason you only have to remember one of them is it depends on how we're going to use it. So let's take a look at converting 45 degrees to radians. Here's what I want to do. 45 degrees to radians. I'm going to take 45 degrees and I'm going to put it over 1, and I'm going to multiply it by something. And it's going to be one of those formulas. Well, the only thing that I have to remember is I have to have degrees in the bottom, because what I want to happen is I want the degrees to cancel. Well, how do I get the degrees in the bottom? Well, that's 180 degrees, and pi goes on the top. So if I cancel 45 and 180, that should be about 4. So I'll end up with pi over 4, and I know that that's radians. Likewise, if I have pi over 2 radians, and again, I'm going to put that over 1, and I'm going to multiply it by something. And I want that something to have radians down here. And why is it? Because I want the radians to be able to cancel. Well, what's the ratio? It's 180 degrees over pi radians. Well, guess what? The radians cancel and the pi's cancel, and we end up with 180 degrees over 2, and all of that's over 1. Well, that's not necessary. All I have to do is have 180 degrees over 2, which I know is 90 degrees. Now, I said earlier that pi over 2 radians, if we go back up to this piece up at the top, I said that pi over 2 radians is 90 degrees right here. And we just calculated by using algebra that pi over 2 radians in fact is 90 degrees. That's exactly what I said it was going to be. Okay, so let's recap. Lines and angles. We have acute angles and we have obtuse angles. Don't worry about negative angles. I'm not going to worry about that, and I'm not going to worry about anything greater than 180 degrees because I would measure that as a negative angle, and I'm not going to worry about it. You need to remember complementary and supplementary. I'm going to ask you about that. Okay. Parallel lines cut by transversal. You got, looks like 8 angles formed. If I give you one angle, you should be able to fill in the balance. You should know what alternate exterior and alternate interior angles are. And on the trig functions, you've got sine, which is the opposite over hypotenuse. Cosine is adjacent over hypotenuse, and opposite over adjacent is a tangent. Now, what I was taught is sine, cosine, and tangent. Okay? That's the way it shows up on your calculator. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Let's have a little lesson on that calculator again. I want to make sure that you understand that when we talk about the calculator, I go to mode, and for the most part I want this degrees set. You can set it in radians, you can set it in degrees. As far as radians go, I want you to remember that 1 radian is the length of the arc that matches the radius. There are 2 pi radians in a circle. You should be able to convert from radians to degrees and degrees to radians. I keep wanting to ask you guys if you got any questions, but that's not going to be possible on the video. So at this point, we'll call it a day.